bones generic model, right? When I don't know what I want to create, I don't have a typology of it, right? Or even if it's a building form, you're going to start with a generic model, because if I start here, I can always categorize it as one of these other items, and it'll act and schedule that way. And open the generic model RFT. Okay, so it's a completely different environment now, right? There is a 00 registration mark. It's defined by 2 reference planes, which are pinned, and they're also named. So we kind of touched a little bit on reference planes and what they can do. Here's more so. Everything in the family is by reference planes. No levels at all. There's one level, and that's where it gets placed at with your cursor. So when I load this family in, right, let's say I just had a rectangle in here. When I load it in, it's going to snap my cursor to that center point. So if I want to load my geometry in by center point, I build off that center point. What's nice is I can also build parameters, right? So when I open up that parametric box, so let's just take a look at that while you're, you don't have to do that, just hold, pause and hold. What I can do is, this is the massing family. We're going to build the same thing as a generic model. When I look at the floor plan of that, right, same thing, I see reference planes, but I'm using a dimensional item to push in parametric data, right? So the dimension drives the reference planes, and then the reference planes host the geometry. So it's that hierarchy structure. We're going to build the skeleton first out of reference planes, and then we're going to put a dimensional constraint called a label, right? And then we're going to put geometry into that. So geometry is always last. We're never putting parameters on the geometry. We're letting the reference planes drive that way of working. Okay? So let's recreate that relationship inside the generic model family. Tab through. Okay, so here we are. So the easiest way to make a reference plane, there's 2 ways. I do RP because I use it all the time. It's going to be RP on the keyboard, reference plane. Or I can go under annotate, or excuse me, create, and there's a reference line or reference plane. So this is a new concept, the reference line. The reference line is used for when you're doing angular constraints. And the reason for that is, again, if I do RP on the reference plane, if I were to try and snap to the end, I can obviously snap there, right? But the minute I move that reference line, it's not snapping that plane to the end of that line. And that's because even though you see it graphically as a start and end condition, it's more like a ray, not A-R-R-A-Y, but A space R-A-Y in CAD, where it goes into infinite space. It's like a construction line. And that's why the angle doesn't start. Now if I wanted to constrain an angular element and build off angles, I would go to create reference line, and then the reference line acts similar to a reference plane, but it does give me a start and end condition, right? And it will snap itself. So I need to actually formally snap it by locking it. Then when I move it, right, it'll cut itself for me.
Can you hinge the connection?
Yes, I can. And we'll do that once we get into editing here. But yeah, you can hinge the connection. If I want out, while I'm here, I might as well do it. We will do this together. We can just watch for this one, right? I see my 45 on my 45, right? I'm going to take this angular condition, and I'm going to annotate off some type of constraint, which in this case is an angular constraint. And then I'm going to say that I want to add a parameter to that. So I want to make this flexible. And I'm going to call it angle, right? And then I'm going to type property 45, or do it as 30 degrees, apply, and it'll flex that. Now, our locks, remember when we were aligning things, right? You'll see that it rotated it, cool, but it didn't stay stuck, right? So I need to pay attention to how I'm locking this element, right? Okay. And my angle changes. So now, hopefully, when I change my angle back to 30 degrees, it should stay stuck. There you go, right? because I've locked it now. I've said that, I want you to lock to that condition. Right? Cool. And then what's nice is, even within there, I can create new types, handling different rotations that I can toggle in between. Right? So in this one, I want 30 degrees, and then on type 1, I want 45. Right? So on the fly now, when I'm doing my editing, or even in the family, I'm just saying I want, whatever family this may be, I want the one that has the 30 degree, or I want to look at the one that has 45 degree. Right? I don't have to redraw anything. I'm just changing numbers at this point. Okay. But that's more advanced. Angles are certainly difficult. Gets into trigonometry, SOHCAHTOA, all that good stuff. No calculus, right? There's no hard-end calculus. You really have to script it out to do any calculus with it. Certainly possible, but I don't think you'll ever need to go that far. Go to Grasshopper if you do. Revit has a type of Grasshopper plugin. Again, you still need to kind of know Python a little bit before you do it. Okay, so we should have a reference plane on the left. So if you don't, type RP and do one reference plane on the left, one reference plane on the right, one reference plane at the top, one reference plane on the bottom. Arbitrarily, doesn't matter what the dimensions are. And that's one thing for most architects they have a problem with, because they are accustomed to knowing exactly what I want when I want it, right? And I know I'm going to change it, but in this case, you have to get yourself out of that mentality and realize that you're building a skeleton that's able to be dynamically flexed, right? It's able to move, it's able to function. You're creating a system that's parametric, right? In Grasshopper, I don't come in and immediately say that I'm going to have a box that says this and this, and then start scripting it. No, the idea is to be able to push and pull and iterate and drive different sets of design conditions, and that's kind of what we're setting up here. So the first and foremost easiest way to constrain these reference planes is by doing an equality constraint. So to do any dimension, it's DI for dimension, and that's going to bring up a set of dimensions. Here's your broad scope of what dimensions are, and real power behind them in the family. I can do radial, diameter, arc length, angular, and align. That's basically all I should ever need. I'm going to click. Now, making a dimension and placing a dimension inside here, I'm going to click on the left, right, and you'll see it's waiting for me to find another one. So I'm going to click on the center one. So now it's stuck there. Now it's allowing me to do a dimensional string. So I'm going to click on the farthest one on the right, and then to exit out of the dimension command, if I hit escape, it's going to remove all those dimensions. So I click off into the white space where there's nothing, and then I have my dimension. And if I pause and hold, there's three things that we need to talk about. If I lock this, I lose variability in my system. If I click on EQ, which is an equality constraint, let's go ahead and do that. So I'll click on EQ. It's going to immediately make those two items equal. And if I escape twice out of there, now when I pull one side, it's going to flex, what I call flexing the model. It's going to flex the other side. Okay. Let's do the other one. Let's do DI again for dimension. D as in dog, I as in Isaac. Was it delta? I don't know what the I is. Top, middle, bottom. Click off on the white space. And then this one, I want you to click the lock on one of them. And then escape off. So when I go to move this one, it's going to allow me to flex this one, but if I go to move either the center or the outside or top one, because I've locked it, it's going to say constraints are not satisfied. So when you're doing any family editing, get used to it saying constraints are not satisfied. Because we've locked it, we've ruined the ability for it to be variable. So we want to make sure we leave everything as a variable set. So in this case, I'm going to remove constraints and allow it to flex again. So then by removing the constraint, it's unlocking that dimension. So the dimension is driving, because I've dimensioned to this reference plane, In the family, that dimension is now driving that reference plane and the location. So what I can do is if I want to make those equal again, I select the dimension string, click on equal, and then I can bring them in so they're not overlapping any one of each other. So then that means that my system here is going to grow from center. So as I make my length bigger, my box is going to grow from the center. If I wanted my box to grow from the bottom left, I would build this relationship up in this first quadrant, so on and so forth. If I wanted to go down here, it'd be in the fourth quadrant or third quadrant. Next thing is let's put an actual dimensional constraint on that. So I'll do DI again, and I'm going to do the overall length of my box, which is there. And in this case, right now, it reads as 9 foot 2 inches. At 9 foot 2 inches, if I select that dimension, I get some kind of options up here. Now, the key one is this label. So I created the dimension. I'm going to go to label, and if I click on where it says label, I'm going to say add parameter. So I've got the dimension string that I've created for the overall length selected, and I'm clicking add parameter. So let's talk about this dialog box here. So I can have parameters that are shared, which are shared amongst all projects, right? Or I can have family parameters that are only singular to this item. And then there's this little kind of wording here. So family parameter cannot appear in schedules or tags, right? So I can't pump other information into the project. This is only driving this family, and this will make more sense once we get into rooms and areas and schedules. And then the shared parameter is something that can be used then to make parameters that can be read by both project file and family file. Because remember, we don't have that associativity between the family and the project, right? We kind of explained that, and this is why we need to do something like that. So that would be the way that they become connected. That would be the glue. But we're not going to do that. That's really advanced stuff for right now. The next thing to understand is this type versus instance, right? So it's not like 3ds Max, or it's not like a block. So you think of a CAD instance, that's going to be like a block. Types are different sets of the same family, and they can serve as instances by creating new types. So I rarely ever use an instance property or parameter. The only time I use instance parameters is when I'm nesting families together. So I can take this box family, put it in all of its other stuff, and use it maybe as a mullion in a curtain wall panel. And I can pump those parameters from that file into the new family. But then they have to be instances. That's the only time. And we'll talk about nested families too a little down the way. So mostly everything I do is going to be a type parameter. You can always go back and change a type parameter to be an instance if you need it to be. However, if you have an instance and try to change it back to a type, it's really, really difficult to manage when you have objects already placed in the project file. So always, always, always start at the type. Very, very, and again, take it for out of faith that rarely will you need an instance parameter. And a lot of times they muck people up. The other part is that I have a certain set of objects that are now grayed out. So if I were to start without selecting this dimension string and went through my type editor, which we'll do that as well, I would be able to change my type of parameter. Because I've selected the dimension first, it automatically reads this as a type of parameter. So we'll do this, and then we're going to do another one the long way and show you why it's better to do it this way. So let's just go ahead and call this box length. And SGA standard is to always capitalize user-created variables. So we'll call this a variable definition. And click OK. I've selected the dimension string, and then I go up to label, and I click on add parameter. Okay. And then that's one way to do that. The other way is I'm going to do DI for dimension and put 1 for width. But I'm not going to select it and go through the options bar. To change this value, at the top left are 4 buttons. Okay? And those 4 buttons are very crucial for any family editing, and they're going to appear in every family editor. The second quadrant, so you remember from physics class, excuse me. First quadrant, second quadrant, third quadrant, fourth quadrant. So in the second quadrant, the bottom right is a family types button. If I click on that, it brings up now those values. So you'll see, even though I don't have a parameter shown in my file for that angle, it's still in there. So it's basically defining variables that then can be assigned to specific dimensional objects. So in this case, we want to add a parameter. So on the right of this dialog box, are you okay? Do you got this up? Okay, good. So I can click on add, and it's going to bring up that same dialog box. And then under that dialog box, under type of parameter, you'll see that I now have access to create any variable I want. I can do textual data, I can do integers, numbers. So what do you think an integer is? Full numbers. Number is going to be the decimal number. Thank you. We remember college or high school algebra. We can do length, we can do area. So area, what would be the units on area? Square feet, A+. What would be volume?
All these answers.
Come on, you need an A+ for the day. Come on.
What's that?
Volume. What's volume?
Cubic feet or inches?
Oh, it was supposed to be gap. So she's trying to make up for those
Ounces.
twos. All right, angle. Right, we've already done angle. It's going to come in degrees. So, and the reason why I kind of bring you through this is because these values are crucial. If I'm going to calculate an area from something, right, it's not going to automatically assume that 2 lengths multiplied equal an area or a square footage. It's going to want me to specifically define that. And if I don't specifically define that correctly, it's going to throw me an error, right? So let's go ahead and, in our case, we're defining a new parameter that's going to be of a length because it's going to be our box width. So I'm going to do a length. So length is just length. It's dimensional. And I'm going to call this one box width. And then always get in the habit, if you're creating family parameters through this route, not through selecting and then modifying, I need to always make sure that it's not 0, 0. It's got some type of value. And that's just, it doesn't have to be that way, but there's other cases where it does have to be that way, so I just always say make sure you put in a value so you don't run into problems. And I click apply. So let's not leave this value yet, okay? You'll also see that I can do formulas, right? So basic formulas, I can do if statements, let statements, if this, then do this. That's really advanced stuff. I can also do just multiplication formulas. So let's calculate a floor area from this, or an area, box width times box length. So I need to add a container of information to house that calculation. So I'm going to click on add, and I'm going to go to area. So my type of parameter is now area, because I'm calculating 2 lengths, 2-dimensional lengths. And I'm going to call this box underscore area. And click OK.
Did you say covers and string areas so you can remove one slider like the one cover?
That's how my parametric box works, yes. Space planning tool. You can also, and really what that is a derivative of, like I had a student build this same lesson, right? We spend the 3 weeks just building things off of this little lesson. So like a space frame tool, right? I click and draw a line. Like I draw a wall, right? I click a point and then another point, and it populates a full space frame roof for me, right? Based on this idea of the box. So it's all possible. This is like the root foundation of all. If you can build the box, it's like the school of Mies. If you can build the box, you can build anything. And same is true in Revit. You understand the box, you should understand most of it. So under the box area, I do box width times, so my times is all up at the top keyboard. Shift 8 on the keyboard is my times. If I wanted to do divide, it would be the slash. Again, plus works, minus works. Any case where I can do divisions within this, right? So I can do 2 divided by 4. So this is going to be box times 2 divided by 4, which is 1/2 of the box width. Whoop. Right, so it's just like plugging into a graphing calculator, times box underscore length, right, 4.58. I can even make these values x and y, so I can do new containers of data. So let's do that. Let's make so our ratio. We set up a ratio value. So I'm going to add a parameter called x, and this is going to be a number, or we'll do it as integer. So let's do integer x, and then we'll do another parameter, integer y. And then we'll say integer x is 1/3, right? So y, x. And then we can add another parameter, which is a number, which is ratio, which is then x over y. Apply. So give me 1/3. Whoop. Yeah, that's fine. So that's x over y. And then I could say box width times whatever ratio is now. Oop. End of expression. Make sure you get your parentheses in there. Apply. Invalid formula found in ratio parameter in the blah blah type. So type. Or edit the formula to continue. Okay. So it's most likely because it's numbers and formulas. Yeah, that's what it is. So in this case, right, so I've done this as a number, and then this is a number as well. Because of that calculation, and let's unlock those, actually. Try that. Oop. Because these are dividing, x divided by y is giving me 1.33. These really need to be numbers, so you need to have matching criteria. So I need to come in and modify that. Oops, when I go to modify my x and my y, because I've already defined this, I can't change it, right? So I'm going to remove x, or remove y. And in this case, because y was defining ratio, I have to delete that out of ratio first. Remove y, remove x, and then I need to go back and add those in again and make sure I get them. So being aware of kind of what you're doing ahead of time with this is really, really essential. So I'm going to add in y now and to make sure that is type of number, right? So it's always hard to change variables, containers once they're assigned. Make sure this is 1.0, this one is 3 point, or this one is 1.0, this one is 3.0. Ratio is now equal to x divided by y. That should, import the correct table or edit the formula in order to continue. Okay, well that's funny. Why is it doing that? Case does matter, so you notice I did lowercase. Case absolutely matters. That's weird. It's saying.
Oh, it's because you have 2 quotation. No way.
No.
Never mind.
No, in the type. Let's try making it an instant. Maybe that's fine. Oh. Yeah, it's something funny there. So let's try and remove that. Yeah, it could be. Oh, I know why. Haha. Key thing. So you'll see that I've gone in and I've made a type 1 and a type 2. Because type 2 has a different set of values with my calculation, it's not going to let me do it because it has to be true for all cases of types. So when you're defining parameters, Always make sure when you're defining variables that you don't have any types defined yet. So now when I go to do my ratio, it'll be 3.0, 1.0. Now my ratio will work. Yeah, that helped me. Thank you. Mine works. There we go. So that works. So then now I can come into box area. I make that mistake every time I do this. Apply. Okay. So there we go. So that works. Right? So kind of makes sense to everybody. Everybody got a working formula? All that good stuff.
Try and
Let's click apply.
Ratio returns 0 for some reason.
See there? Resume. Okay, so there we go. So that's flexing it. Now I want to set up test conditions, right? Because I'm going to begin constraining my kind of Swiss box here. Swiss box, Swiss watch. So I want to, now that I have all of my parameters working, my formulas are working, they're kind of gelling together, now I create new family types. And that's more so I can create a test condition, right? Flexing the model is what I call it. I need different values for each type so I can see the model move and see where it's breaking, right? Because we need to establish locked relationships to make sure this thing works, just like gears, right? If I have a gear out of place, the only way to see a gear out of place is to turn the other gears, okay? So we're going to go ahead and create a new family type, call it test case A, and then do a new family type, call it test case B. And then on test case B, we'll leave test case A's values the same. Test case B, we'll give it some different values. I just, doesn't matter what they are. Fairly arbitrary. Maybe we'll change the ratio here as well. Right? Okay. And I'll click apply and click OK. So now I need to actually constrain the rest of my floor plan of this box. So I'm going to select my right dimension, which was going to be my width. Do you guys need me to slow down a little bit? Or are you keeping up? You're good. And then under label, so I still need to assign this a variable, right? Just because I define it doesn't mean it's associated with it. It's data associativity, associative design, data associative design. I'm going to do box width now, so I'm going to tell it that this side is box width. I could also tell it to be box length, right? You'll notice that we made several other parameters for this. However, that specific box width is only queuing up, or this length is only, or dimension is only queuing up length parameters, right? It's not pulling up the area as an option. Only things that are applicable to that are an option in assignment. So I'll do box width, right? You'll see on my test case, right? So I have some kind of clutter. So at this point, I'll make sure that my test cases have room to grow, right? Just more so of just me being able to see what's going on, making sure that all the reference planes cross each other so I can see intersections of them, right? Just convention. That's my bad habit of just cleanliness inside the family. Okay. And then with that iteration set up, yeah, you can't move the centers. You don't want to move these guys. These guys we don't want to move. And they're pins. You can unpin them and move them, but generally you just leave them pinned. What I'm doing is just pushing and pulling that reference plane so I can move that out. And again, it's an infinite space, so I don't need to do this. I just do it so my own eyes don't go crazy, right? Again, in the center points, I can't do that because they're pinned. Okay. So before we go any farther with it, I want to go back to my family types. So there's a lot of redundancy of repetitive steps in this. I need to go back to my family types window. We'll be opening and closing this window fairly often, so get used to it. I need to toggle between test case A and test case B to make sure it actually works and does what it's supposed to do. And then on test case A, I'll even make this 3 feet so I can see that a little bit better, right? So we make sure that everything moves before we do any kind of modeling or any kind of geometry.
So you're just testing to see if changing the chart changes the
Yep.
numbers on it?
Yep, it's testing my gear ratio here.
Cool.
And it's
I mean, you have to apply.
yeah, you always got to hit apply. Get in the habit of hitting apply. I've been yeah. All right, so that's one. Now the last part of this is I need a height to my box, right? So let's put in a parameter called box height, and make sure it's of type parameter length. By default, it's always going to do a length parameter because it's the most commonly used. Do box height. Click OK. Click apply. Then I'm going to come in and go to the elevation view. So this is your project browser, but it's not that I can create new views or section cuts or anything like that. Pretty much what you see is what you get. I'm going to go to the front view of this, and you'll see I have my reference planes that I've created. I need to create a new reference plane, RP, cancel that, and put it as the height. Right? And we don't want to make it angular. We want to make it actually so it's the height. Okay. And then I'm going to take that, and you'll see when I select that reference plane, I can still dynamically change it, right? So a quick shortcut to putting the dimension on it is to click that little dimension string, and then I can take that dimension string and assign it a box height.
Do reference lines work the same as the section lines where you can align them all if you want to? Kind of take one and then like drag it down and have these other guys?
No.
Okay.
Because again, they're infinite.
Right.
Yeah, and again, it's more graphical why I move them, not functional that I move them, because they are infinite.
More gravity.
Yeah. Yeah. So, I mean, and we can go as far as, putting in an angled roof on our little box. We're not going to do that. We can do that a little later. Some things, so let's get in some geometry, right? So I'm going to come into my reference level. I have my box working. I'm going to check my family types, make sure that on both my test cases that I have a height associated, so box height is the same in both cases. I'll want to change my box height in one case to be something smaller. So I see it flex in 3D when I'm done. Click apply. Good? You knew I was going to come by. Yeah. All right, so now creating geometry. So I go to the create ribbon. And when I create ribbon, it's like AutoCAD solid modeling. If you haven't taken a look at the new modeling tool since like 2011 in AutoCAD, really I have extrusion, blends, revolve, sweep, sweep blends. That's it. That's all of the modeling tools I have available to me. So let's take a look at what each one does. Solid extrusion. It's all based on a sketch. It's a simple just up and down. And we're going to do this in the conceptual mass environment and really watch it go. So here is solid extrusion. I can do a blend, right? So if I do a blend, blend's going to go from top to bottom. So I have a top plane and a bottom plane. And then I blend the two objects together. So those can be parametrically defined. Why are you shaking your head? Who, this guy? I do it too.
Sorry, I really.
I'm a musician, so I always crack my fingers. Bass player, man. Revolve, right? If I want to do revolve, I need to, one, define a profile and a revolve axis to revolve around, so that creates my shape, should that be. So a little bit more thought process goes into these shapes and what you do create. And it's more so because this idea that I can make every one of these shapes parametric, I'm fairly limited to what I can use and can create. They have to be solid objects no matter what. Otherwise, they can't be calculated, they can't be parametrically defined. Revit, again, is not a surface modeler, it's a solid modeler. Sweeping profiles work the same way. Kind of getting into the family editing mode, we'll talk about that once we get this broad brush scope done. And then also the sweep blend is going to go from one to the other, 2 shapes across a path. Right, so this is like sweep 2 rails in Revit, or a Rhino kind of deal. Or a loft along a path. Right? And then my void forms. So I'm going to do a void extrusion. I watch this video. You'll see that I take one and it's going to cut that object out as a negative. I've never actually watched the void videos here. So we're going to go through and watch each one. See what they do. Ah, nice. Very nice. Right, so I think these videos are pretty self-explanatory. We'll go through each one of these, right? Not necessarily the voids, but we'll definitely go through the solids so you guys get a feel for it. Because once we get to the massing environment, we don't have these tools. There's no button for it. It's the way you create it. Revit just knows that that's what you want. Void sweep, let's see what it does with this one. This is going to be interesting. Same box, cool. Ah, clever.
Somebody calls it.
Very clever.
Void city.
Yeah. Cool. Make sense? So in our case, most of the stuff you're going to do in Revit, well, in this office, probably not so much extrusions. You'll be doing a lot more kind of creativity and also needing to use Rhino for a lot of things. Extrusion is all we need at this point. I'm going to click on extrusion. I enter into my sketch mode, so similar to the way I make editing a profile on a wall or making a new floor. I'm always entering into a sketch command and then saying what I want. So you're going to have to follow along here well with me. So, or good. I'm not bad at those 2 words. I think the terminology and me describing that was incorrect as well. We'll go to the rectangle, and I'm going to hover over the intersection point there, and I'm going to drag down to the intersection point at the bottom right. Now if I pause and wait, you'll see 4 little lock buttons. So what do you think those lock buttons do?
Find the edges of the rectangle to this reference line.
Exactly. So let's go ahead and lock them. But I'm not going to lock the one on the right, so let's leave the one on the right unlocked and check. Right? And let's turn on our shaded view. So now I see that I have some gray in there, so it must mean I have some type of geometry. I go to the family types. I'm going to test case, so I'm going to toggle between test case A and test case B and click apply. And it looks like it actually stuck. You gotta be kidding me. Well, that's nice. Well, it didn't break like I expected it to break. What should have happened is on the right side here, if I drag that off, right, it should have not adhered to that. So if I pull that side off with the grip editor, so I've selected it, and I've clicked on the right side, and I've dragged that off, and I go to my family types to do my test case, what you'll see is when it breaks, right, or something's not stuck or not locked to that reference plane, it's not going to flex the model appropriately. So what I need to do, what do you think I would use to then get that relocked? You got it, A+. I do AL for a line, A as in apple, L as in lion. Click on the right reference plane as the object I want to align to, and then I select that face and lock it.
Sorry, I missed a step here. After you draw the rectangle.
That's okay. That's okay. Check and flex it. Make sure everything's stuck. So the best way to do that, you need to turn on your shaded view.
But does it automatically lock to the references when you draw it? Or do
If you click the lock button, yes. right? So if I don't click the lock button, when I go to drag that off, I want to remove my constraint. When I drag that off, you'll end up with conditions where the geometry is not flexing with the model, right? So to get that relationship back, I can use my align tool, or I can just click the grip, drag it up to that reference plane, and then it'll come up with a lock as well. I don't like using the grip as much as I like using the align tool, because at least with the align tool I have to be explicit with what I'm clicking. There's going to be issues where you have multiple reference planes, and getting it to snap on the right one with your cursor is somewhat difficult sometimes. So last time I've kind of tried to break this thing several times. When you're doing any family editing, you're going to fail at it a lot. Things are going to break a lot. You're going to get into doing the same box probably 20 times along the course of your careers in Revit. This is probably the 10,000th box I've made like this, so I can quickly go through and be done with it. You guys, it might take you a little bit of time, so I definitely suggest going in and trying to create the box on your own. So let's go to the front view now, and the last part. What do you think I need to do with this? There we go. Now you got your A+. So let's go ahead and everybody should be getting A+. So I'm going to go ahead and drag that up and then check. And then I'll do my test case in the height value as well. Make sure that flexes. Okay? Cool. So let me look at my notes here. Pause this. Very, very important.
That will get confusing.
Yep, very, very important. Very, very important. If I come into another view, all of a sudden, and I've made this mistake too, it's like, well, wait a minute, I thought I constrained that. Why am I seeing it, right? Not realizing that all I have to do is constrain it in one view, and it's a global constraint. It's not a regional constraint. So if I were to come in and dimension and try and constrain again in that same view, that length or that width, because it's already defined somewhere else in another view, it's going to give me labeling this dimension would over constrain the sketch. So it's going to tell you, hey, dude, you can't do that. So again, I would just then take it and say, oh, that's already defined somewhere else, so I would delete it off. We can get all that into this little box here, make a little Swiss box. Okay, so within here, I need to put a parameter called material, right? Material parameters and visibility parameters are not like the length and width. I can define them through the family types. However, I cannot do it associated with reference planes. And why do you think that is? It's a material and it's visible. I'm making objects visible, I'm making objects have a material. The key word in all of that is the idea of object. It's associated directly to the object. I can have multiple objects in the same family housing different sets of material parameters. So the material is not a global, it's object specific. Therefore, I need to select the object itself and assign visibility to it within that case. So in this one, I'll say, we'll go to 3D, and I'm going to select my object, which is my box. Turn on my shaded view. And I'm going to go to the properties of that box. And then within the properties of that box, you should see a materials and finishes category. Now, I can easily come in and say that my box explicitly has a material called glass, and it's always going to be glass. So if that's the case, I'm going to just come in and assign it right here in the properties and give it glass and be done with it. However, if I want to be able to change that material inside the Revit project, not the Revit family, but the Revit project, as we did with the types, I need to give it a parameter or a variable giving me the capability to do so. So let's go ahead, and instead of going into where it says by category, there's this little kind of hidden button. It's always the hidden buttons and the tiny buttons that do the best bang for your buck in Revit. So it's called the Associate Family Parameter Value. I'm going to go ahead and click on that, and it's going to come up and say, I am a family parameter of material, parameter type of material, and I'm going to go ahead and add a parameter. So it's going to bring up that same window that we're familiar with. I'm going to default it to gray as a material parameter. In this case, I'm going to call it box material. I'll leave it as a type, and I'm going to click OK. Click OK. Okay, then come in there. Now, when I come into my parameter values, when I select my object, now the material function in the properties is grayed out. And that's because it's now driven by a parameter. It's not driven explicitly in the family, which means I can explicitly define that somewhere else. I can drive that again somewhere else within the project specifically. I'll go to family types, and then again I have test case A and I have test case B, right? So on test case A, we should see now box material as available category. That means I can test different materials as well within this. Okay. So on test case A, we're going to come in and click one, and now in the family, my materials are very limited in the family, and that's because no matter what I define in here, if there's a Revit material of the same name in the project file, it's going to trump that material I set up in here. And then also, it's assuming that you are going to drive materials from the project and not the family level. But we can, for testing, to make sure it's taken that value, we can assign basic ones. So I'm just going to take my default, give one a color of red. I'm going to rename that default as box, or call it red. I'm going to right click and I'm going to duplicate that one, and I'm going to call this one blue. This one will be blue. And then I can also change it on surface pattern, right? And that's the elevational view for this. I'm not going to worry about it. You would want to change it there as well, right? If we want, we can change it once we are here. Change it to blue. Back to red. We'll change to red. Pretty easy to pick red and blue. Click apply, click OK. Then on box material red on test case A, test case B is going to be box material blue. Click apply. So then it turns it blue. If it doesn't turn it blue, raise your hand and I'll come by. We need to make it so it goes blue. Good. So parametric arrays are handled a lot differently, right? So within this, because I've made this box so many different ways, and I've constrained it, I don't want to put in a bunch of stuff within here yet. So we'll kind of wait till the last part for that. Visibility settings work exactly the same way as material settings work. You'll see that I also have is visible or is not visible. Now, when I load this into my project, that's when I'm actually going to have the capability to do that. So because visibility is also something only specific to the object, not to the whole way and structure of calculation that the family is being made, again, I click that radio button next to visibility. I'm going to add a parameter. In this case, I'm going to make it an instance. I'm not going to make this one a type, but I'm going to make this one an instance. And I'm going to call this box visible. And click OK. And then it's checked by default. So when I select it, now it's checked and grayed out. I can't handle it right here. So it means I need to go to my family parameter. And then because it's an instance, I really don't need to worry about it. But the key thing is in the variable itself, you'll see this word called default. So for some reason, that's Revit's default, and that's not correct. It shouldn't be that way, but it is. That's the way Revit does it. So anytime you see default in parentheses next to a parameter, that means it's an instance parameter. So if you're having problems with a family not acting right, that's the first thing you look for is that default, right? It's like, oop, it's breaking. That's your default, defunct, I call it. Right? Okay. So we're just gonna leave that as is, and we're gonna check on both cases and make sure that's checked, and we're gonna see how that operates per family, right? So that's it for that family. Let's click apply and click OK. Let's go ahead and save it out. So save it to your desktop. Call it Sweet Bird, we'll call it Sweet Box. And we're gonna go ahead and load it into project and make sure we're gonna load it. So now when I go to load it, so I've made this family, it's not loaded into anything else. Now you'll notice that I have the capability to load families into other families because I have my parametric box open. Or I can load it into other Revit projects or multiple at the same time. So if I know I'm going to use this in multiple pieces, I could do that as well. In this case, I'm just going to load it into that imports example file. I always load families and test them outside of the actual working project file first before I load them into a project file, especially one that everybody's working on, because I'd hate to load something in that doesn't work and then confuse everybody, right? So I'm going to load it into my session 2 first. If it works, we'll load it into the other one. Okay? Click OK. It'll open up the file, and then it's going to be waiting for me to place that object. So it's right now Sweet Box Test Case A, and it wants me to place it. So I place it. And I want to place a few of them there, and I'll place 3 or 4 down here. Okay? Now, let's say I bring it in and I bring it into a view inside that project that was a 2D view, or it wouldn't let me show it in that view. In order to bring that in again, I go into my generic model category, because remember we created this as a generic model. And if I underscore, I should see Sweet Box under my family/project browser. And I should see my test case A and test case B. So in this case, let's bring in test case B. So I'm going to drag test case B over, put a couple of those in. Okay. Now I have several of these, so if I wanted to change one of my newly created boxes, I can come in, select it, and I can change it to test case B if I want, right? So I have the ability to do that. Or we can create one and call it test box C. So let's make a new type and call it test box C. So within my Sweet Box, I'm going to right click on it within my project. I'm going to say I want a new type of Sweet Box called test case project based, right? Just so we keep a firm grasp on what we're doing with each one. And I'm going to drag project based in. And then on project based, I can go in and change the parameters of that by right clicking and going type properties. And then you'll see all of those parameters that I just defined are now available to me to change. So it should be similar to, if I edit a window, that's all somebody did. So somebody back in the Autodesk office, once this software was developed, had to sit down and say, okay, what kind of window are we going to do? And they built out a window with all these parameters. So that's all they did. And now that's all you did here. So you're able to create your own parameters, do your own sets of values. And it's also pumping back data to me. I'm able to change ratios on the fly. All the things that I created in that family are now available to me in a nice, neatly wrapped user interface. So I can do box width is maybe 24 feet for this one, with a height of 50 foot by another 50 foot.
Looks like you have a lot more material options once you're editing this in.
Correct, and exactly, because in the family or in the project, I have all the materials that are associated with that project. I might have been making concrete, all these other things. That's why I generally just assign a material parameter to the object, make sure that it's on and stuck, and then I do my material editing in the project. Yeah. But the key thing is especially for, just get in the habit of always putting material on new families. Put a material category on there. Be nice to people. Be nice to your fellow workers. Be nice to people like me that have to export it and troubleshoot it, because not having a material parameter on there really kind of, especially when you get a big project that's so far down, if you've done everything as default, it really becomes difficult sometimes. So just make sure you get into the rigor. It's like assigning layers, right? Parameters are now like your layer rigger.
So when you double click on one of these elements and it opens in a new family file, if you save that, does it update the project?
Yeah, if you save over it.
Save over.
Yeah, yeah. Now, one last thing is we assigned a visibility parameter to these, right? So I have, let me go ahead and delete out that new case. So because it's an instance, right, these are types, right? So everything but our visibility parameter, we made a type parameter. And these are test case B. So on test case B, if I change the width to be 3 feet on all of those, it's going to change all of them to be 3 feet, okay? If I make it an instance, when I change that instance, even though it's belonging to the type, it's only going to change that one particular instance of that type, which is their reasoning behind the instance. So if I go to its properties, I open this up, right? I don't see that visibility anywhere. Where I do see it is when I select that box and I go to the properties, that face value always are instance properties here. So if I have to go to edit type, I'm editing it for all of them. If I'm editing it right here, I'm only editing for that specific one. So you can see I'm turning them off now, but it's not turning off all the other. Make sense? Perfect. Cool.
So once you turn off box visible, how do you get it back?
Good question, sir. You don't.
Are you serious?
Nope.
What do you do?
Nope, nope, nope. So that's where, again, nope. It's there. Well, you would set up a schedule. It would schedule as it's still there, and then you would have to use the schedule, the database side of Revit, which we haven't got into to actually select it. So yeah, it can be dangerous putting visibility parameters on things as well. Be very careful with this. Yeah, I mean, literally 85% of what you're going to need to create, you can do based on the principles out of that. So that's our box. It's 2:48, so let's go ahead and take a break.